Welcome back to All This Math. This is Professor Parker, and today we're going to talk about air travel word problems. We're going to go over a word problem, actually one word problem, that deals with air travel. On a plane flying around the United States of America, that's what we're going to get into. All right. Now, the actual word problem, as you can see, is not written on the board because I wanted to conserve space on the board for my calculations. But the actual word problem is found in the description underneath of this video. Make sure you are subscribed to the channel and also like the video and share the video with other people too. All right. Now I'm going to read the problem and I'm going to refer back to it, repeatedly as well. So here's how it goes. Two planes leaving from Atlanta, Georgia. All right. Hartsfield, Maynard Jackson International Airport. Right. One makes a 5.2-hour flight to Seattle, Washington. The other makes a 2.5-hour flight to Boston, Massachusetts. The plane to Boston averages 44 miles per hour slower than, that's an important phrase, slower than, very important, the plane to Seattle, Washington. If the total distance traveled by both planes is 3,124 miles, determine the average speed of each plane. So again, this is a word problem, and this helps us develop our consequential thinking ability because you see the if-then statement. If the total distance traveled by the planes is such and such, 3,124 miles, then what's going to happen? Or then what would that mean? What is that? How does that affect the speed, the average speed of each plane? All right. And we can figure that out using a formula. All right. So whenever you approach a word problem, what I suggest is for you to try to include or insert yourself into the word problem. So start thinking about when you've been in Atlanta. Start thinking about when you flew a plane or took a flight from Atlanta or took a flight from anywhere, really. Think about a time when you might have went to Seattle, if you've been to Seattle. Think about a time you might have went to Boston, if you've been to Boston, right? Or if you flew anywhere. Start thinking that way because then the word problems become less abstract. They become less intimidating. They become less complex in your approach to them. All right. They start to become more like just scenarios, like, real life scenarios. That's what they start to feel like. All right. Before we start the problem, though, I meant to do this when we first started. I got my Republic of New Africa t-shirt on. Right. If you're not familiar with the Republic of New Africa, please go do some research on the Republic of New Africa. All right. Some of the people that were associated with the Republic of New Africa, you have the late Chokwe Lumumba, the former attorney who was for a brief period the mayor of Jackson, Mississippi. Chokwe Lumumba, originally from Detroit, Michigan, I believe. Also Robert F. Williams, check him out. Do some research on him. He actually wrote a couple of books, Radio Free Dixie and also Negroes with Guns. So check out his work and check out his history. Also, little known fact, Rosa Parks was associated with the Republic of New Africa at one point. So look into her relation to the Republic of New Africa as well. And also Amari Obadeli Williams. I think I'm saying his name correctly. Forgive me if I'm not, but I think the brother's name was Amari Obadeli Williams. He was one of the leaders of the Republic of New Africa, which was essentially an idea for people of African descent in the United States to claim land in the southeast section of the United States. So in this word problem, we're talking about taking a flight from Atlanta. If the Republic of New Africa had come to be, then Atlanta would be a city that was actually controlled, owned, operated, and run politically, economically, culturally, and socially by people of African descent, if that plan had come to fruition. All right, but definitely do your research on the Republic of New Africa and also the people that I named, and also you will find names of other individuals that are relevant to it. And also there are people still to this day that are promoting the idea of the Republic of New Africa. So shout out to them. All right. Now, back to the word problem. Two planes flying from Atlanta, Georgia. And I'm reading the problem again because another thing I suggest you do whenever you approach word problems is to read them for a minimum 3 times. A minimum of 3 times. All right. Don't get so worried about it, how long it's going to take. Read it a minimum of 3 times. The first time, it's going to make a little bit of sense. The second time, it's going to make a little bit of more sense. The third time, it'll make a little more sense. So 2 planes leave from Atlanta, Georgia. One makes a 5.2-hour flight to Seattle, Washington. The other makes a 2.5-hour flight to Boston, Massachusetts. The plane to Boston averages 44 miles per hour slower than the plane to Seattle. If the total distance traveled by both planes is 3,124 miles, determine the average speed of each plane. All right. So first thing I'm gonna draw a little like rough sketch. I'm not gonna sit up there and draw the United States of America and draw all the 50 states and all that. But what I'm gonna do is this. I know that, let's say Atlanta was right here. Let's say this is Atlanta, right? One of the planes is going to Seattle. So if it's going to Seattle, it's going this way, right? The other plane is going to Boston. I know in relation to Atlanta, Boston is up here, or like straight up somewhere, right? Right? Now, of course, Seattle is further away than Boston. You know that from just taking a cursory look at any map of the United States. Also, think about the amount of time that it takes in the problem to get to Seattle. It takes 5.2 hours to get to Seattle. It only takes 2.5 hours to get to Boston. All right. Now, when you see a problem like this that deals with time travel, deals with speed, right? And it deals with a distance traveled, the time taken to travel, distance traveled, and speed. This is a DRT, what I call a DRT word problem, meaning that we use this formula. Distance equals rate times time. DRT. Make sure you write this down. Distance equals rate times time. Now, what is the rate? It's the rate of speed. So really it's speed, right? R is really speed, but R stands for the rate, but it's the rate of speed. So R represents the speed that either the plane is traveling, the person is traveling. If it's another type of word problem, the boat is traveling, the car is traveling. What else? I think that's about it. Yeah, planes, trains, and automobiles. Planes, trains, train. The train is traveling, planes, trains, automobiles, and boats, right? So that's the rate of speed. The T stands for the amount of time that's taken, all right? And D stands for the distance, okay? Now, this problem says that the total distance traveled by both planes is 3,124 miles. So in this case, our D is 3,124 miles. But let me break it down, though. This is how we know this. Imagine each of these planes has their own DRT, right? Their own distance, rate, time formula. The plane to Seattle has one, and the plane to Boston has one. So basically what we're doing is we're saying the distance to Seattle, I'm going to put an S right here, equals RT, and the distance to Boston equals RT. So each of these planes got their own distance, rate, time formula, right? But the problem tells you that the total distance, meaning this number plus that number, which we don't know what individually they are, and we don't care, right? We don't need to know. You might think you need to know, but you actually don't need to know in order to answer the question that you're being asked. You're being asked the speeds of the plane or the rates of the plane. So those are the variables you're going to solve for, right? But you know that the total of each of these is 3,124, right? So watch this. So that means that I'm going to set my equation up like this. I'm going to add these two distances together. But if I add the distances together, distance of Seattle and the distance of Boston, that's going to be equal to RT plus RT. So we got RT, I'm going to put it in parentheses, S, the rate times time of Seattle, plus the rate times time of Boston. So let me pause right here for a minute to make sure that this makes sense, because this might be the most difficult part of this whole problem, setting up the original equation. We were told in the problem that the total distance traveled was 3,124. Total, when you see the word total, that means addition. You added something to something else, all right? Or adding a bunch of things together, but you're doing addition. The distance to Seattle plus the distance to Boston equals a number. That number we know. But then the question is, but then what's that equal to? If we need an equation, we need to know what that's equal to. If we already knew that the distance to Seattle was equal to the speed of that plane plus the time travel, or times the time traveled, right? And we knew the distance to Boston was equal to the speed of that plane times the time traveled, then doesn't it make sense that if we combine the distances, then we should also be able to combine the speed and the time, the product of the speed and the time for each of the planes. Doesn't that make sense? So distance to Seattle plus distance to Boston is equal to the speed times time to Seattle plus the speed times time to Boston. That's a fundamental concept. That's a concept that you have to grasp. And this is like, before we even start doing any algebra, we got to understand the principles of algebra to know how to set up the equation. Because once you set up the equation, everything becomes much easier, but you got to set up the equation properly first. All right. Based on the information you're given. We know that the total distance traveled was 3,124 miles. That's what we know. So this is going to become 3,124, 3,124. But the question we got to answer is also, well, what is this equal to? If this was already equal to this, and this was already equal to that, then we should be able to add these two together. And then they should be equal to the total distance. That should just make sense. I mean, like, think about it. If x equals 5 and y equals 10, then wouldn't x plus y equal 5 plus 10? Because you add in what they're equal to together. This is kind of like a representation. Well, it's a representation of the transitive property, right? So if this is equal to this and this is equal to this, then this plus this should be equal to this plus this, because they're each equal to their corresponding things. All right. Now, let's move on. The problem told us that the total distance was 3,124 miles. So we're going to replace this part right here with a number, 3,124. Now, let's talk about the Seattle plane. This plane right here. In the problem, it says this. It says the plane to Boston averages 44 miles per hour slower than, remember I said in the beginning of the video, slower than is a very important concept, very important phrase. Slower than. It's very important. Whenever you see that in a word problem like this, slower than the plane to Seattle. When you approach word problems, right? My recommendation to you, whenever you have a sentence and a word problem where two things are being compared, whether they're speed, distance, travel time, ages, whatever it is in the word problem, when two things are being compared, what I like to do is I look at the second thing in the comparison, and I automatically make that X. That's my X variable. The second thing in the comparison is automatically my X variable. That's what I do all the time. You don't have to do it that way. You can make the first thing the X variable, but I like to make the second thing the X variable. And then the other thing that's being compared, that becomes an expression based on X, based on its relationship to X. So watch this. It said the plane to Boston averages 44 miles per hour slower than the plane to Seattle. So the plane to Seattle, I'm going to call that speed. I don't know the speed of the plane to Seattle. The problem didn't tell me, but I don't need to know. So I use a variable to represent what I don't know. We use letters or variables to represent what we don't know. So we're going to call this X. That's the speed, right? So, but if the Boston plane is 44 miles per hour slower than means whatever speed this is, you subtract 44 miles per hour to get this speed. So whatever speed this is, you subtract 44 miles per hour to get this speed. Again, whatever speed the Atlanta ATL to Seattle plane is going, you're going to subtract 44 miles per hour to get this speed. So this is going to become X minus 44. So that's X and that's X minus 44. That's going to replace the R's. R is the rate of speed. This is how you do these problems. You got to really take your time with these word problems. Break them down sentence by sentence, word by word, phrase by phrase, and really understand the relationships between the information and the problem. And also understand how that information is going to fit into your formula and how it's going to fit into your equation that your formula comes from. All right? Or the equation that comes from the formula, rather, I say. So now, for the plane to Seattle, this R becomes X. Right? So I got my parentheses and I got an X. This is RT, which means R times T. There's no multiplication sign between. So that means R times T. So now we go back to the problem. We say, okay, well, how long was the flight to Seattle? How long was it? The problem tells us that. So we know that number, right? The flight to Seattle was 5.2 hours. So we're going to say X times 5.2. So look what I just did. What happened to the R? The R became X. Why did the R become X? Because in the problem, the speed of the Seattle plane was talked about second. And I always make the thing that's compared to, or the thing in a comparison word problem, which this is, the thing that's mentioned second, I always make it X. The flight to Seattle was mentioned second. The flight to Boston was mentioned first in that particular sentence when they talk about the speeds. So the R becomes an X. Now, what about the time? Where does 5.2 come from? Because when you read the problem, it says the flight took 5.2 hours. So that means we replace the letter T with the number 5.2 because time is 5.2. Time is 5.2. So now this is the part where we just replacing letters with numbers. That's all we doing. And we just got to, if you put the numbers in the right places, then you're going to be straight. You're going to be good. It's just like putting away your putting away your clothes after you do laundry. You got to put everything in the right place. Putting away the groceries after you go grocery shopping or after you get your Instacart delivery or whatever you do, right? I stopped messing with them. The fees got too high. But anyway, you got to put everything in the right place. You're not about to put the ice cream in the cabinet because it's going to melt and go bad, right? You got to freeze the ice cream. Put the ice cream in the freezer. If you put the numbers in the right places, then you'll get the right answer. All right. Now let's talk about the Boston plane. The Boston plane, right? The rate of speed is this expression. Now, some people get confused when they say, well, shouldn't it just be one variable or one number? No, sometimes it's going to be an expression. It's going to be this whole expression, x minus 44. That's a binomial. It's called a binomial because it's got two terms. Like a bicycle has two wheels. One term, another term, two terms. So we're going to replace the letter R, put your plus on, with x minus 44. Now here's something else that could be tricky. Inside these parentheses, you need to put x minus 44 inside of its own parentheses. So you're going to have like parentheses inside of parentheses, right? Be mindful of that, right? And then this is going to be multiplied because this is R and this says R times T. Because if you don't put the parentheses, what's going to happen is it's going to look like you're only multiplying the time by negative 44. But you actually are multiplying the time by this whole expression. So that's why you got to put the parentheses around x minus 44. You got to do that. All right. So now the time for the Boston plane is, according to the problem, go back to the problem and read it. It says 2.5 hours. It's a 2.5 hour flight. All right. So now you got times 2.5. I ain't had to put the dot. I could have just wrote it adjacent to the parentheses, but since that had a dot for multiplication, I decided to be consistent. So now our equation is set up. So now you got to know how to do the algebra. Now you got to know how to do the algebra and solve for x, because once we solve for x, we're going to notice the average speed of the plane that flew to Seattle. And then we're going to know the average speed. We're going to be able to figure out the average speed of the plane that flew to Boston, because all we got to do to get the speed of the plane that flew to Boston is take the speed to Seattle and then subtract 44 miles per hour from that. And then we're going to be done. All right. But actually, no, we're not going to be done, because as a habit, I also recommend you check your work. So we're going to go back and we're going to check our work by putting our speed values or our rate of speed values into this equation and make sure that the left side is equal to the right side and make sure everything checks out. All right. So look, so what should we do first? So what I'm going to do is this. I'm going to kind of clean this up a little bit. So this is going to be 3124 is equal to, now I'm going to put the 5.2 first because that's like a coefficient. And then I go, so this changed into 5.2x. So notice what happened. Commutative property, I just put the 5.2 in front of the x. That's all I did. I didn't actually do anything. I just rewrote it. All right. Now, plus sign. Now, 2.5, we got to distribute. So remember distributive property. 2.5 got to get multiplied by everything inside the parentheses. Not one thing, but both things. 2.5 times x and 2.5 times negative 44. Both things. 2.5 times x and 2.5 times negative 44. You got to multiply by both, because the time must be multiplied by the rate of speed. And the rate of speed includes both of these values, the x and the negative 44. All right, so we're going to have 2.5x, because 2.5 times x is 2.5x. And then 2.5 times negative 44 is negative 110. And don't forget, that's a negative 110. That's not a positive 110, because a positive multiplied by a negative always yields you a negative product, always. All right, so now look at this. Now it's getting more simple. Now what I'm going to do next, it's a lot of things I could do next, but the next thing I'm going to do is I'm going to combine like terms. What are like terms? Terms that have the same variable, that have the same exponent. So this has an x to the first power. This has an x to the first power. This is 5.2 of them. This is 2.5 of them. So altogether you have 7.7 of them. So we got 3124 is equal to 7.7x minus 110. So as we progress through this problem, and as you should do in class or wherever you are, whenever your professor or your teacher progresses through a problem, you should always make sure how everything, like where did everything come from in the progression? Like, as this changed from this to this, how did that happen? As this changed from this to this, how did that happen? Like, where did the 7.7x come from? Adding this to this. Where'd the negative 110 come from? Where'd the negative 110 come from? Multiplying this by this. So you have to make sure you know where everything came from. That's your responsibility as a student. Know where everything came from one step to the next. It's like watching a movie, from one scene to the next. How did this person get here? How did this character get here? I mean, that's why, like, when you be watching Tubi movies, sometimes it's like, what? Where did you even come from? Like, that's why I like those movies, because they, you know, they're not supposed to be funny, but they be hilarious sometimes, because stuff don't be making sense. But anyway, 3124 equals 7.7x minus 110, right? I'm trying to solve for x. That's my ultimate goal. I want to solve for x. So I got to isolate the 7.7x first. So how do I do that? I get rid of the negative 110. How do I do that? I add 110. I do the opposite operation. You do the opposite operation. So I do plus 110 on the right. And if I do it on the right, just like ancient Kemet, Mayat, I got to stay balanced. So I got to add 110 on the left. Boom, boom, boom. 3124 plus 110 is going to be 3,234 is equal to 7.7x. Now we're getting close. We're getting real close. We got one step left before we solve for x. So what's going to happen is we're going to get rid of this 7.7 to isolate x by itself. And then we're going to have our answer. We're going to know the speed of the plane to Seattle, right? And then we can figure out the speed of the plane to Boston. So we divide by 7.7 because, why divide? Because that's the opposite of multiplication. And why do I care about where the multiplication come from? Because 7.7x means 7.7 times x. That's multiplication. So the opposite of multiplication is what we do to get rid of the 7.7. So we're going to then divide this by 7.7. Cancel that out, and then we're left with just 1x. This becomes 1. 1x is the same thing as just 1x. Well, 1x is the same thing as just x. Put that in your calculator. 3234 divided by 7.7 equals 420. So that means that the flight to Seattle, that plane was on average going 420 miles per hour. 420 miles per hour. That's what it was doing. It was doing 420 miles per hour. Now, so that means that the flight to Boston was doing 420 minus 44. Now we just got to do arithmetic. 420 take away 44, right? 420 take away 44. So I would do 420 take away 40 first, which would give me 380. And then 380 take away 4 would give me 376. So that's 376 miles per hour. Now, how do I prove it? 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 I prove it by going back to this right here, right? This right here. And I replace all the numbers, because before I didn't know what x was. I didn't know what x was, right? But now I do. So now I want to see if this is a true statement. So I want to see if 3124 is equal to Seattle flight 420 times, how long was the flight? 5.2 hours plus Boston flight 376 times 2.5 hours. right? We want to see if that's true. So we want to know if 3,124 is equal to all of this over here, all that over there. So let's see. This is going to be 2,184. This is going to be 940. And then we're saying that 3,124 is equal to that. And in fact, it is. When we add it up, we get 3,124 on the right, and we had 3,124 on the left. So that's a true statement. That's what math is about. That's another aspect of math that our ancestors in ancient Kemet talked about, and the other African ancestors talked about, was that the purpose of math is to find the truth. We want to find the truth. We use math to find the truth. So therefore, this is a true statement. 3,124 is the same as 3,124. So we need values that solve the problem, that give us the truth. We don't want values that give us a lie. People lie to us all the time. We get lied to every day, right? We don't want those answers. We want the answers that are going to give us the truth. This answer right here gives us the truth. This answer right here gives us the truth. All right? That's another benefit of checking your work. All right? So, and this is how we do some of the travel word problems that you may see, whether it's a problem dealing with, you know, the distance speed, or the time of a train, a plane, a boat, a car, a bus, whatever, right? You follow this formula right here. This is a very important formula. And then you derive other formulas from it, because it wasn't straightforward. Like sometimes you gotta you might have to subtract like you might do D equals RT minus RT. So, it gets complex at times, but as long as you understand this formula and you understand the word problem and you read it and think about what's really happening, then you'll know how to apply this formula. Like we had here, we had the formula twice, because we had the formula for Seattle, for the Seattle plane, and we had the formula for the Boston plane. So we had to combine those two formulas. We had to combine them because we knew the total distance traveled. So if we know the total distance traveled, that means that we have to combine the rate times the time of the Seattle plane with the rate times the time of the Boston plane. And then once we do that, we just plug in all our information, and then we proceed to do the calculations until we simplify everything down to just this. And then from there, we figure out the speed of the Boston plane, and then we go back and we check our work, and boom, we find that it's correct. And if we had found that it wasn't correct, we would have had to go back here and find our mistake. And if we couldn't find our mistake, maybe our check would have been correct, because that happens sometimes too. You know what I'm saying? So yeah. So that's that. But you got to practice these problems. You got to practice them. I know I was saying a whole lot, but you can pause and rewind, run it back. Run it back from the top if you need to. Whatever you got to do. But you got to practice these problems. You can't just watch this one video and be like, oh, okay, I know how to do these now. No, you don't probably, right? If you had no idea how to do this before this video, and you watch the video, now you feel confident, that's cool. You should be confident. Confidence is cool, but you're really going to be confident when you know what you should do? You should, I was going to say you should just make up your own problem. I wouldn't do that because, well, actually, I guess you could. You could. I mean, the numbers might come out kind of crazy, but you could just make up different numbers. Change the amount of time on the flight, 5.2 and 2.5, change those numbers. Maybe change the total distance. Pick some other cities, do whatever. So you can make up your own problems. Ask your professor for a problem. If you're taking a college course, ask your teacher for a problem. If you're, in high school or whatnot, looking at these problems, or if you're just a parent that wants to help your child, you can just go online and look up distance, rate, time, word problems, or travel word problems. You can just look that up, but you got to practice, right? It's not enough just to watch the video. Like math is not a spectator sport. You can get some guidance from watching the video, use the video as a reference, but you got to go practice. All right. So go get some practice, and I'll see y'all on the next video. Peace.